What causes acid rain, and how do we diagnose diabetes from urine? My name is Ben from O-Chem Condensed, and in this video we will be reviewing the essential functional groups in 5 minutes that shape the world around us. Let's go. Okay, our first functional group is alkanes, an unreactive hydrocarbon. Alkanes are burned every day as fuels, including methane gas, propane tanks for barbecues, butane lighters, and gasoline. But in chemical reactions, other than burning, they're mostly unreactive. Alkenes are hydrocarbons with carbon-carbon double bonds. They are also components in fuels, but much more chemically reactive than alkanes, and are precursors to many of the plastics that we use every day, unfortunately, like styrofoam, polyethylenes used in plastic bottles, and cutlery. Alkynes are hydrocarbons with carbon-carbon triple bonds, and they are also used as fuels. Oxyacetylene torches combine oxygen and acetylene into a flame that burns at 2000 Celsius. Benzene is an unusually stable form of hydrocarbon with a surprisingly sweet smell. Too bad it causes cancer. Because of this smell, the word aromatic is also associated with this chemical stabilizing effect that benzene's 6 cyclic electrons have. Everybody's heard of alcohol, which is ethanol, but did you know that if we drink methanol instead, which is very similar, we actually go blind? And did you know that the last resort treatment for methanol poisoning is to drink ethanol? Ethers are oxygen atoms sandwiched between alkanes. They have very particular odors, and diethyl ether was used as the first anesthetic for surgery, although it sometimes caused you to never wake up, so it's not used anymore. Epoxides are small cyclic ethers that are strained into small 3-member rings, making them more reactive. They are great electron acceptors, also known as electrophiles, and are commonly used in the synthesis of molecules. Ketones feature oxygen-carbon double bonds and are the major components in ketone bodies, water-soluble molecules produced by our livers when we have no sugar to burn. They are expelled in our urine, and we can use them to diagnose people with diabetes. Carboxylic acids are, well, acidic and sour. The sourness of vinegar comes from acetic acid. Surprisingly, acetic acid is only one more carbon away from propionic acid, which smells like body odor. Don't put that on my fish and chips. Esters are some of the sweetest smelling molecules around. They make up most of the aroma molecules we deal with every day and are the smells behind some of our favorite fruits like pineapples, pears, and strawberries. Acid chlorides are a more exotic and reactive functional group in organic chemistry. They're made from carboxylic acids, hence the name, and produce acids when reacted with water. They are even better electron acceptors than epoxides and are commonly used electrophiles in the synthesis of molecules. Amines are alkanes with a nitrogen substituent. They are great nucleophiles which attack electrophiles and are the decay products that leave old fish with that particularly unpleasant fishy smell. Amides are the linkers of amino acids that make life as we know it possible, and also make up peptides and proteins. Yes, technically that protein, but also 3D peptide-containing proteins. Nitriles feature carbon-nitrogen triple bonds. Cyanide, the most popular poison in murder mysteries, is reported to have a somewhat sweet almond smell, but is tasteless, making it the ideal poison. Nitro groups are commonly found in explosives, the most popular example being TNT, or trinitrotoluene. These shock-sensitive molecules are devilishly hard to handle, and for this reason are rarely used anymore. Sulfides are the sulfur versions of ethers. They generally taste and smell quite bad and are a common byproduct during the beer brewing process. Failure to remove these sulfides yields quite an unpleasant lager. Thiols are the sulfur version of alcohols and are alternatively called mercaptans. They are added in small amounts to natural gas to give it that nice rotten egg smell. When sulfur is fully oxidized, it's called sulfate. These ionic molecules can be protonated twice to produce sulfuric acid, a very strong acid used in synthesis and a major contributor in acid rain caused by the burning of fossil fuels. If amides are the linkers of amino acids, then phosphates are the building blocks of DNA. When they are linked together, they also make up part of ATP, or adenosine triphosphate, the energy molecule used by cells to drive processes like muscle contractions. Here's a summary of these functional groups. That's all for this video. If you enjoyed the content, hit the subscribe button. Thank you all for watching.